name is Xinjian, a PhD student coming from University of Virginia. Today I'm going to use stick figures to show you how to design an energy harvester circuit. Are you ready? Let's start!
In our daily life, there are so many electrical devices around us, such as an iPhone, watch, monitors, and sensors. For sensors, there are so many applications. Some scientists will throw them into forests to collect the data, like humidity and temperature. Oceanologists will put sensors into ocean to detect the ocean flow. Biologists will stick sensors into some animals to track their location and population. But all the devices have a common problem. They will need batteries. So we need to charge them every day or use plugs. The emerging technology, energy harvesting, can help us solve this problem. An energy harvester can collect energy from the environment. They can collect energy from the light, heat, human body vibration, and signals in the air, like 4G, 5G, and Wi-Fi. So energy harvester can collect energy from the environment. Other components will consume this energy. So we can get rid of the battery. You can think of energy as the food for devices here. Now researchers are focusing on improving the energy harvesting ability to collect more food for all the components on the chip. Or they try to decrease the power consumption to make components eat less food. By this way, we can build many self-powered devices. Now we can start to design our energy harvester. First, the idea. We want to design a chip that can be implanted under our human skin. We can detect our health condition and send this information to our cell phones so that we can monitor the patient's health condition at any time. And don't forget, it should power itself without battery. So the first question is, where is the energy coming from? Here we assume that the energy is from our body motion. Then the functions. It should monitor our body temperature, blood pressure, the ability of sending information. It also needs to power itself. Okay, great. Now we can think about the circuit structure. The energy harvester will send energy to the sensors, which is for detection, and then the data will be sent to CPU and memory, which are for data processing and information storage. Finally, the transmitter will send out this information. And don't forget, we need a clock, which is counting the time. Now let's begin our energy harvester. The first step for us is to convert the vibration to energy or current. So we need a transducer. As you can see, at the end of the transducer, there is a large mass. So if your body is shaking, the mass will shake as well. As the mass vibrates, the front magnet will follow the mass to vibrate. So the distance between the two magnets will keep changing. Finally, we can get current or electrons or the food for the devices. But sometimes the current or the electrons are flowing from the left to the right. Sometimes they will flow in the reverse direction. So the current is a kind of AC current. It's unusable. So the next step for us to do is to make the energy usable. Here, we need a rectifier. The principle of the rectifier is very simple. You can just treat it as a traffic control strategy. The input is a two-way street. Current can flow in two directions. The diode are placement. They only allow the current to flow in one direction. So the top electrons cannot turn right. It has to go straight. The bottom electrons cannot turn left. Finally, the output will become a one-way street. All the electrons are flowing in one direction. Now the energy is usable. But the problem here is that the current is unstable. Sometimes it's large, but sometimes there is little food coming in. So the third step, we need to add a capacitor here to make the current stable. You can treat the cap as a food pool, which can store some electrons. When there is enough food coming in, we can store them in the pool. In this way, we can provide a stable food supply for all the components in the chip. Okay, now we're arriving at the final step. For all the devices in the chip like CPU, memory, card, they're doing different kinds of work. Some work is so hard, like CPU and memory, they need to do so many calculations and remember everything. But some work is very easy. For example, the clerk's work is just counting the time. So they need different voltages. Higher voltage means higher calorie food. Here we need a DC-DC converter to change the voltage for them. We can treat the DC-DC converter as a food factory, which can provide different kinds of food for all the components in the chip. In this way, all the components in the chip have a stable supply of their favorite food. They can keep working forever. We can get rid of batteries. So finally, we use the energy harvester to supply all the components in the chip, and we use the transducer, rectifier, and DC-DC converters to guarantee the energy is stable, reliable, and satisfying for all the components on the chip. Now, the sensor can work without a battery.
Remember, this is a simplified example about how to design an energy harvester. There are so many other kinds of energy available around us. They are waiting for our explorations. Come on and join us. Let's design better circuits. See you!